Okay guys, so we're gonna start the first day of rational functions. Okay, so you can see rational functions. Basically what it is you have a fraction, and in the numerator you have to have a polynomial, and in the denominator you also have to have a polynomial. And the rule of thumb right here, that denominator is not allowed to equal 0 in all cases. If you can find a value where it's equal to 0, we call that undefined. Okay, so just to go over polynomials, have just a little review here that you can go ahead and read. So polynomials just has many terms. You can have constants, you can have variables, but you can't divide by a variable. Your exponents, something that looks like a polynomial, well, it would be 3x, x minus 2, x squared, y plus 2y. These guys are polynomials, but as soon as you look at negative exponents, like x to the negative second power times y, not a polynomial. 1 over x plus 2 is not a polynomial. 3 to the x, those aren't polynomials either. They're different functions. Okay, we studied this the last goal. This is a rational function. We're going to study that right now. Something interesting, the name of your graph for the rational functions are called hyperbolas. So if I refer to a hyperbola, it's just what the picture is going to be. And then you're going to learn something, you'll see this letter U. So that's the symbol for union. And this symbol is going to join things together, and we're going to use it for the domain and range. So basically, let's move on. What we want to do, so for your first example, is really just take a look at the parent function in the graphing calculator. So I'm going to go ahead and bring up a graphing calculator. Alright, so there's your TI-84. So we're going to go to y equals. And basically what we're going to do is just do 1 divided by x and graph it just to see what this puppy looks like. Oh, there you go. Alright, so you got some curvature going here, other curvature going there. So if you take a look at this, the last goal we talked about vertical and horizontal asymptotes. We're going to see a lot of that here. We're going to see maybe one of them. So there might be just a horizontal asymptote, there might be just a vertical asymptote, or there might be both. So every case is a little bit different. So let's do second and then graph to get the table up. And you can actually go ahead and copy the input and the output. So go ahead and copy the x and the y. Okay. And then you can see when we get down to 0 here, for the y, it gives you this error. Okay. Alright, so you can graph that in your own calculator. So I'm going to go back to here. So we go here, going to this first question right here where it asks where is this undefined. When we got this error here, that's going to be undefined at x equals 0 because, well, that would be 1 over 0, and you can't divide that. You can't divide 1 by 0. That's undefined. Okay. Are there asymptotes present? Well, heck yeah. The asymptotes in this case, you have a vertical asymptote. That's this red line right here. That's going to be the equation x equals 0 for your vertical asymptote. And then you have also a horizontal asymptote at y equals 0. So remember, those are the lines that those curves approach. They never touch it, so they're never going to be actually x equals 0 or y equals 0. So for our purposes, we're just going to do these quick graphs. So we're not going to really bother with, graphing the x and the y. We'll just make a quick graph. Okay, so that's the parent function exploration. So what I'm going to do is actually stop that here.